We have a model in Azure ML. Now what do we do with it? Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel. I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. The prior video in this series ended with us training a model using the Azure ML Designer. This video picks up where that one left off. We're going to use the Azure ML Studio to generate an inference pipeline so we can make use of our model. By the way, as far as terms go, you'll hear people interchange the terms performing inference with generating predictions or even performing scoring. There can be minor nuances to each of those three variants, but I'll save that pedantry for the comments section. Just know that, for the purposes of this video, I'm not going to distinguish between these concepts. Now, there are two types of inference pipeline we can work with. The first is called real-time inference, and the idea is that Azure ML will stand up a web service with a REST API as a front end for our model. We can pass in data and it will return back our input plus the predicted output. This works best when predicting one row at a time or in small batches, such as if you have a web interface in which you accept form data and post a request to an API to generate a result that you can display back on your page. The upside to this method is that you get results back in a short amount of time, hundreds of milliseconds to a few seconds, depending on network latency and how complicated your model is. The downside is this won't scale. If you try to include 1 million rows in your post request, it'll take quite some time, no matter how simple your model may be. That's why we have the other option available to us, batch scoring. Batch scoring is great for cases in which you have a large number of rows and want to perform inference on each row. The interface for batch scoring involves dropping files in a known location, typically with each line representing an observation for inference. Then, Azure ML can operate on this data, perform inference on each observation, and write the results to a different location in a storage account. For this video, we will perform real-time inference. In a future video in this series, we'll perform batch scoring, but that won't be for a little while yet. That's the overview. Now let's see what we can do in our demo. This is a real-time inference model that I've created. It allows us to generate predictions based on the Chicago parking tickets fixed model that we built in the prior video. If I switch over to the endpoints view, I can select Chicago parking tickets and see the REST endpoint and Azure Container Instance endpoint available to me. Taking that, as well as some test data that I can generate from the Test tab, I'm able to switch over to Postman and predict whether our model thinks a person is likely to skip payment. It's as easy as that, but let's see how we get there. Switching back to Azure ML, let's navigate to the Jobs tab and select our Chicago Parking Tickets Designer experiment. As you can see here, I have a few successful runs of jobs in this experiment. I'm going to choose the latest, and it will take me to a designer overview of each step. I'm confident in this model and want to make it available to the rest of my team. So how can I do that? The first step is to select the Create Inference Pipeline button in the top menu. This allows me to create a real-time or batch inference pipeline. As I mentioned not too long ago, real-time inference is best for relatively small batches, maybe 1 to 100 at a time. That's what we'll choose in this demo. This now takes me to a new pipeline, which looks kind of like the training pipeline, but not quite. We can still see the Chicago parking tickets data file input, but now there's another input containing transformation rules that we built in the training pipeline. These feed into an apply transformation component. This allows us to prepare the data in the same way that we did for producing the model to begin with. Then we feed that prepared data into the score model component. This component takes an input of a trained model in addition to the prepared data and does the actual prediction generation, or scoring. It writes out the resulting predictions to our web service so we can consume them. This model is partially complete, but not totally done. First of all, we have no way of getting new data into the model. But that's an easy fix. All I need to do is drill into the Web Service Component dropdown and drag on a new Web Service input. I can wire that up as an alternate dataset for apply transformation very easily, and now I have a model which is okay. The reason I say it's only okay is that the way we have things set up, we need to include a payment is outstanding column in our input. Our model doesn't use that column for scoring, so we could always send in 0 or something if we don't actually know the answer, but it's a little weird to send to the model the thing that you want the model to estimate for you. So let's get rid of this annoyance. To do that, I'll delete the original Chicago parking tickets dataset. Next, I'll bring in an enter data manually component. Double-clicking on the component allows me to import data of my own choosing, and I happen to have a very small sample of this dataset minus the payment is outstanding column, but including all of the other columns. After that, I need to add an edit metadata component, as Azure ML is going to think that my issued date column is a string rather than a date time, so I need to fix that. To do so, let's connect the dataset from enter data manually into edit metadata. Then I'll double-click the component and select columns. The column I'll choose is issued date. Once I select that column, I can change the data type, which I'll switch to date time. From there, I need to use a format. Azure ML uses Python string formats for date, so I'll tell it that my data is in the format year, month, day, then a space, then hour, minute, second. Now that I've created a template for what that data should look like, let's hook the dataset back up and then bring back our web service input. The last thing I'll do is delete the evaluate data component, which evaluates scored results against actual known results. Well, we don't know the answers, so this component won't help us at all. If I've done everything correctly, I should be able to select validate and get back a note that the pipeline looks good. It does, so let's submit the job. I'll select my existing Chicago Parking Tickets Designer experiment and leave the rest alone, then select Submit. On the left-hand side, I can see the running job. Let's select Job Detail and navigate over to it. This brings up a new Azure ML Studio tab, and we can see the job already in progress. Let's fast forward until the work is done. In real time, this took about 2 to 3 minutes, and I now have a real-time inference pipeline. But nobody can use it yet, not until I select Deploy. This takes me to a window where I can set up a real-time endpoint. If I choose compute type, we can see the 2 options available to us: Azure Kubernetes Service or Azure Container Instances. AKS is the go-to option if you're creating production-ready services, though there's quite a bit of administration overhead involved, and you'll want to be fairly familiar with Kubernetes and container administration as a result. If you're just messing around with things like I am, Azure Container Instance is an easier path to getting going, but it lacks the uptime guarantees or performance scaling of AKS. In the Advanced tab, you can see the options available for us when I select Azure Container Instance. Because we're dealing with a simple model, we can leave the CPU and memory reserve capacity alone. But know that these are here if you need them for larger models which may require more RAM or compute. I can also enable transport layer security, though it's labeled here as SSL. But I already have an endpoint that I'd like to replace, so I'll choose this option instead and select Chicago Parking Tickets. Clicking Deploy once more containerizes my pipeline and deploys it to an Azure Container Instance. If I navigate to the Endpoints menu, I can see that Chicago Parking Tickets was just updated. Then, clicking on the endpoint itself, we can see that its deployment state is healthy and operation state is running. If you're creating a new endpoint, note that this may take 20 minutes or so to deploy the new endpoint and get it into a healthy state. In the meantime, a brand new endpoint will report being unhealthy until then. In my case, I already have an endpoint, so it'll still take 20 minutes to update, but at least I can continue in the meantime. Let's navigate to the Consume tab. At the top, we have Basic Consumption Info. This has two things, the REST endpoint and two valid bearer tokens. The REST endpoint is where I need to go to make API calls and score results. But unless I have a valid bearer token, calls will fail. So I'm going to need to copy the endpoint as well as one of these two tokens. Why are there two? Well, because you're probably going to want to cycle the tokens periodically, so you can update your app and use the other token and then regenerate the old one without any app downtime. Scrolling down a bit, we see ways to consume our API, and there are examples in Python, C#, and R. You can, of course, use other programming languages as well, but these are the three they give us for examples. I'm actually going to use none of the above and will instead make a direct REST API call with Postman, an API testing tool. To start, I'll switch over to the Test tab. This gives us sample data we can use to make a call. I can copy this and use it as a starting point for my tests. Over in Postman, I already have a test available called Predict Payment. This test hits my endpoint. On the Authorization tab, I've set the type to bearer token and pasted in that token from the Consume tab in Azure ML. Then I pasted the contents of the test section into the body and made sure that the input is in raw and in JSON format. If I did everything right, I can select Send and it will make a call against my endpoint. Here are the results from my web service output. First, we get back all of the input columns. Then we get two new columns, scored labels and scored probabilities. The label is our prediction on whether payment will remain outstanding, and the probability is the actual probability for the underlying call. For example, here our label is 0 and the probability is just shy of 0.5, meaning the model is quite unsure of itself but just barely believes that payment will clear. As we move on, we see other examples in which the probability is lower, indicating that these are less likely to be toss-ups like the first one. By the way, let's go back up to that first example. The issued date for this is the year 2000. If I mess around with dates, I can move the needle a little. So let's say that the issued date was 2012, leaving everything else alone. Now when I run, we see that the probability is just over 0.5, so the score label changed. So that's our model out here for the wide world to see, or at least the part of the world which has that important bearer token. Creating an inference pipeline wasn't quite as in-depth as training a model, though there were still plenty of steps along the way. But let's take a step back and talk about what we did. With a bunch of mouse clicks and a bit of judicious typing, we trained and deployed a model in Azure Machine Learning. This is a real model which actually works, and we can call it either directly or from code. It's hard to beat this combination of simplicity and utility. But there is a gray cloud behind this silver lining. The Azure ML Designer is rather limiting in terms of what you have available to you. There's only a certain amount of functionality, and that doesn't change frequently. Also, if you need multiple variations of a model, it can get rather tedious. That's why, in the next video, we're going to switch out of the designer and move into code-first machine learning with Azure ML. We'll have links and show notes in the description below. And until we see each other in the next video, take care.